This video will cover section 4.7, Inverse Trigonometric Functions, and I don't want you to confuse this with the term reciprocal. I will explain that. Inverse Trigonometric Functions. The objectives will be to evaluate and graph the inverse sine function, to evaluate and graph the other inverse trigonometric functions, and to evaluate the compositions of trigonometric functions. We know that for a sine function to have an inverse function, it must be a one-to-one function. And so the way that we test a function to see if it is a one-to-one function, we draw a horizontal line. If you were to draw a horizontal line, you could see it's not a one-to-one function because it actually touches the function in this case in 3 points. But of course it will actually be infinitely many because the domain of the sine function is all real numbers. So it is definitely not a horizontal, it doesn't pass the horizontal line test, so it is not a one-to-one function. Now the way we are going to find the inverse of it so that it's still a function is by restricting the domain, and it's going to go from here to here. So in other words, we're just going to take this little part of the function, which is what we have graphed over here. Now, if we do a horizontal line test on this function, it will definitely pass it. We only touch one point of the function. However, when we restrict the domain, we're going to restrict it specifically from negative pi over 2 to pi over 2. And that is what we have here. If we wanted to look at it as an interval, it would be square bracket because it is included. In fact, you could see it's a solid point, so that means it is included. So negative pi over 2 is included. And everything in between, every single little degree angle measure here in radians, and we have here all the way to pi over 2 included as well. So from that interval, we have the following 3 properties. So the function is increasing for that particular interval that we selected. Also on that interval, the function is taking all of the range, the full range of values, meaning from -1 to 1. You could see them all are present here. So the sine function, or the output, it will be from -1 to 1. As an interval, remember, we write that this way, -1 to 1. This will be the range, and this will be the domain. And this is still the sine function, but restricted. Now, on that interval, as we said before, we could guarantee that the function is a one-to-one function. So on that restricted domain, from negative pi over 2 to pi over 2, and what we have here is an inequality that is, you could read it from the middle to the left. It says x is greater, because the inequality symbol is opening towards the x, so that's greater. X is greater or equal to negative pi over 2, but also x is less than or equal to pi over 2. That's how we read it. So the function y equals sine of x has a unique inverse function called the inverse sine function. Now, I said at the beginning of the video, don't confuse this with reciprocal, and so I'm just going to write this real quick. Reciprocal, two functions that are reciprocal could be the sine function and also the cosecant function, because the cosecant function is 1 over sine of x. That is what it means to be reciprocal. Now, inverse, we do have a different notation for it, and it will be, it looks like it is an exponent to the -1, but we read it as sine inverse of x. That is exactly how we read it, and that is the notation that we will use. Now, another notation for it is what we have here, arcsine, that is how we read it, the arcsine of x. So both notations, they imply the same thing, the inverse sine function. And the term arcsine comes from the association of the central angle, as we discussed at the beginning of the course, with its intercepted arc length on a unit circle. So arcsine means the angle or the arc whose sine is x. And so just like with every other inverse function, the domain and the range will be interchanged. So again, for the sine function, y equals sine of x, we have the domain is equal to all real numbers, and the range is equal to -1 from -1 to 1 included. But remember, we had to restrict the domain. So we changed that to -π/2 to +π/2. And in fact, we did say that we're included, so I'm going to go ahead and change this to the square bracket. Okay, so that is for sine. Now, if we talk about sine inverse of x, in this case, the domain is what used to be the range here from -1 to 1, and the range is going to be what used to be the domain in the sine function. So with the sine function, with the original, the one that we looked at first, our input here used to be the angle measurement in radians or in degrees. That was our input. And our output used to be a number that was between -1 and 1, like 1/2, the square root of 3/2, the square root of 2/2, and so on. Now, when we move to the inverse or the arcsine, the question changes. The input is going to be the sine value, and the output or the answer will be the angle measurement. That will be the output. And so with these things, with this type of inverse functions, we'll be able to get a number, a trigonometric ratio, and then figure out what the angle that corresponds to it will be the answer to. So again, both notations imply the same, arcsine and sine inverse, and they're both commonly used in math. And remember that it's not the reciprocal, it's not 1 over sine, but inverse. They're very different. In this case, the 1 over sine is the cosecant of x, and that is one of your reciprocal identities. Okay, so the outputs, as we already discussed, are going to come from here, from -π/2 to π/2. And we also see the inequality symbol has the equal here because those two numbers are included. Also, that's why we use square bracket. And you could see that graphically, you could see that with the solid points that we have here and here. Okay, so this is a better representation, the one on the right side. However, you could still see the same thing. The domain is going from -1 to 1. That's the domain. Oh, by the way, I should mention this. Yes. This function is the sine function with the restricted domain, okay? And the one that we have on the right is the actual inverse of the sine function. So it is restricted for the, okay, so let me say this again. The sine function is already with the domain restricted, right? So it goes here from negative pi over 2 to pi over 2. And then the range is from negative 1 to 1. So now what we see here is that what used to be the range for sine now is being the domain for the sine inverse. So this number should be a negative 1 right here. We have the positive 1 here. Now, for the sine function, the domain was restricted from negative pi over 2 to pi over 2. So that is what we could see here for the range of the inverse function. Remember, for inverse functions, the domain and range interchange. And that happens because inverse functions are reflections of each other across the y equals x line, the identity function. So in this slide, we just have the same thing, but with the formal definition. And the definition of inverse sine function is defined by y equals arcsine of x if and only if sine of y equals x. So remember in pre-cal 1, if you don't remember, it's okay. What we used to do there, one of the first steps to find the inverse of a function was to interchange x and y. And so that is what is happening here. So don't be so confused about having y here as the input, and just try to focus for this section on the definition of the inverse function. So the input will be those numbers, the domain from negative 1 to 1, and the output, the range, will be the angles, and they're going to be from negative pi over 2 to pi over 2 included. So I want to relate this quickly to the unit circle. If we were to restrict those same values that we have here from negative pi over 2 to pi over 2, if I was to go in standard position to pi over 2 right here, that will be pi over 2, correct? Now, if I go again in standard position, but now in the negative direction, that will be my negative pi over 2. And so that is what I want to keep you, and I want you to keep in mind that our answers will be given in this way. So just to clarify, when we calculate an inverse function on the calculator, there is no way that you will get an answer that will be bigger than pi over 2, such as 3 pi over 2, although that could be an answer. Instead, you will get negative pi over 2. So then you have to adjust it to the context of your problem. And if the answer was to be 3 pi over 2 and the calculator gives you pi over 2, remember that negative pi over 2 and 3 pi over 2 are pretty much the same. Well, not drawn like that, but it should be something like this. And they're not pretty much the same. What I'm trying to say is that they are coterminal angles. So 3 pi over 2 is also there because the terminal angle is there, just like the negative pi over 2. But a calculator will always give you your answers within this range. Always, always, always. So if your problem or your question on WebAssign is asking for a positive answer and you get, oh, and this should be positive, and you get a negative one, then you might have to use the concept of coterminal. For example 1, we're going to find the exact value of arcsine of negative 1/2. Now, we're going to do this without a calculator. So I want you to, first of all, we're going to draw the unit circle. And I want you to remember how we purposely decided to restrict the domain of that unit circle. And we said, well, we did it on the sine graph, but I want to show it here on this unit circle. And so we're talking about angles that go from negative pi over 2 to pi over 2. Okay, so we know that my favorite sine is 30 degrees, right? The sine of 30, because it's 1/2 is so easy. And that one is located right here. Um, if this was 30 degrees. Okay. And the context of radians, I could say sine of pi over 6 is also 1/2. So if I was to want a sine value that is negative, but we could only work on quadrants 1 and 4, then the correct one will be for me to place my angle in quadrant 4. Why? Because the y values in quadrant 4 are negative, and that's what I'm after, sine to be negative. Remember, sine is representative of the y value. So at that point, what I'm going to do is I'm not going to go like a full circle, not a full circle, but like almost a full circle. I'm not going to do that. Instead, what I'm going to do is take an angle from standard position, but in the negative direction. And that just happens to be negative 30 degrees. And that will be the sine, the value will be negative 1/2. If we want to write it as radians, it will be the sine of negative pi over 6, and that will equal to negative 1/2. And so to answer our question from here, the answer will just be simply negative pi over 6. Or we could also say negative 30 degrees. That just depends on how WebAssign wants you to answer the question. For our next example, where I like to always draw something because it gives me a very good idea of what to do. So in this case, we have our unit circle, and the sine of 60 degrees is actually equal to the square root of 3 over 2. And radians, we will call it the sine of pi over 3 is the square root of 3 over 2. And that one is located here if this was in standard position. And just to remind you, we can only get answers that are in quadrant 1 for positive angles and in quadrant 4 for negative angles. So in this case, sine is positive, so that means that we're going to stay in quadrant 1. We use positive angles. If we were to go to quadrant 2, we will have to use negative angles to give our solutions. So in this case, we stick to quadrant 1, and our answer for this one, very simple. It will be pi over 3 in radians, or it could be 60 degrees in degrees. And that is just because we are required to give our answers from here to here, from that interval. So our angles cannot be bigger than pi over 2, and they cannot be smaller than negative pi over 2. So even though there is another angle for which sine is also equivalent to that, and I'm going to trace it right here, starting from here to here. And that would also be the sine, and that is actually 2 pi over 3. The sine of that is also the square root of 2, but 2 pi over 3 is not in between this interval, and this is the range for the sine inverse function. So that's why our answer must be in between this range. The next question is more of a tricky question, and if you see It says if possible. Well, guess what? This is not possible because the sine values, they go from -1 to 1. So also, if I show you the sine graph for the little section that we decided to restrict the domain from, that this was a -1 and this was a 1. So what that means is that if this is the range of the sine function from -1 to 1, then the domain for the inverse function must be from -1 to 1. And so what is happening here is that we have a 2. And so for this question, the answer is simply undefined. I'm not sure if WebAssign will have an option that says undefined. Sometimes they have D and E, does not exist, or it might have not possible. So that will be up to the options that you have. Right here we have again the graph of the inverse sine function or arcsine. Remember, they are the same thing. And we also have the table. And so I just want to point out that it goes right here, we're using y as the domain. I'm sorry, no. This is a range still. And here we're using this as the domain. Yes. So if we're asked what is the sine inverse of the negative square root of 2 over 2, and so that will be negative pi over 4. If we were asked what is the sine inverse of let's say here, positive square root of 2 over 2, and the answer will be positive pi over 4. And remember, we have to use the angles that go from negative pi over 2 to pi over 2. Although there are more solutions to this question, our answers must be coming from here because that is how the range is set based on the way we restricted the domain of the original sine function. The other inverse trigonometric function we're going to discuss is the cosine inverse. But before that, let's go and review what the cosine of x graph will look like as a function of x. And so you could see it is the curve that we have here. And if we were to do the horizontal line test, of course, we will fail the horizontal line test because we are touching more than one point with the graph. And for that reason, we will have to restrict the domain just to this little part here. So if we do that, and that will go from 0, this is in radians, to pi. And they're both included. You can see that because we're using the closed circle. Now, we have on the right side the graph of the restricted portion of cosine. And so now if we trace a horizontal line, anywhere we trace it, we are guaranteed to pass the horizontal line test, meaning that this part of the function with the restricted domain from 0 to pi is what we're going to concentrate on from 0 to pi. Okay, so the notation for cosine inverse, we have it here. And please do not confuse that with 1 over cosine like we will do with exponents. That's not the same. They're not the same because this one in fact means secant. And sometimes we use those words interchangeably like opposite, inverse, and reciprocal, but they are all different. This is something that is reciprocal. Or with numbers, we could have an example of reciprocal numbers such as 1/2 and 2/1. That's reciprocal. Now for inverse, we have cosine of x and cosine inverse of x, or remember I told you we could also use the term arc, and that is pronounced arc cosine. Same thing as cosine inverse, they're the same thing. So that is what we call inverse. And then finally, just to clarify, I want to remind you of what is opposite. Opposite refers to opposite sign. So meaning, let's say +3 and -3, or negative pi and positive pi, or negative sine of x and positive sine, oops, not cosine, sorry, oops, and positive cosine, oh, again, positive sine of x. These two are opposites, these two are opposites, and these two are opposites. Opposites just refer to the sign, positive or negative. Inverse is something like this. An inverse with numbers. We have multiplicative inverse. We also have additive inverse. I don't want to get into that right now. But also we could think about inverse operations such as addition and subtraction, or multiplication and division, or squaring something and square rooting something. Those are also called inverse operations, and we use those to solve equations. So please remember, inverse, reciprocal, and opposite are all different. You cannot use them interchangeably. So the third inverse trigonometric function we will discuss in this section is going to be the inverse tangent function. Now, recall that the tangent function graph, it does have asymptotes, vertical asymptotes at multiples of pi/2, or I should say odd multiples of pi/2. And it does have x-intercepts in between the asymptotes, and then it has an increasing pattern, and it's similar to a cubic function, something like that. So it is pretty obvious that if we do a horizontal line test, we will fail that. And so we have to restrict our domain to only one part. And the one that makes more sense for us to choose from is the one that goes from -pi/2 to pi/2. But I want you to notice that we're using regular parentheses instead of brackets, square brackets. The reason for that is that -pi/2 and pi/2 are not included. In fact, they must be excluded because they happen to be the vertical asymptotes that we have right here. So, and that is because the tangent at pi/2, since cosine is 0, it will be something like 1/0. So we say is undefined. And that was part of the, what would that be? The previous section, 4.6. We said that at those points at pi/2 and any other odd multiple of pi/2 will be a a vertical asymptote. And that is actually excluded from the domain. So that's why we have to exclude it from here when we restrict the domain. Okay, so we restrict that, and if I was to graph the inverse of the tangent function, it will actually look like, well, first I'm going to see if the graph is over here. It is here. So let's just look at it when we go to the next slide. Okay, so right here, quick summary for the inverse trigonometric functions. It's very, very good to have when you take your exam. Please make sure you have it handy. So let's go first with sine inverse, or arcsine. And so for those, our domain, the input, will be restricted to -1 to 1, including them. That's why you have that equal below the less than or greater than symbols. The same will go for the arcsine or cosine inverse. Now, the range or the outputs are different for each. For sine, we're going to use -pi/2 to pi/2 included. So with a unit circle, I actually like to show this to my students. That will be the area that goes from here to here, and this is included. So I'm going to put fill in circle. So pi/2 here and -pi/2. So that is for the sine inverse. That's how our answers will be, our outputs. Now for the cosine inverse, the outputs are going to come from the first and the second quadrant. So from 0 to pi. And we also include those because cosine, it is defined as 0 at 0. It's actually 1. And cosine of pi is -1. So they are defined. And so that's why we have the equal part here on the inequality. Now, finally, for the for the inverse of tangent or tangent inverse or arctan, our output, well, our input, first of all, it's very nice because it could be any real number. It doesn't have to be between -1 and 1. And the way we restricted the domain from the original tangent is what gives us the output for the arctangent. So this will be the output. So your answers are going to be in quadrant 1 and in quadrant 4. From pi/2, or I should say from -pi/2 to pi/2. But in this case, they are not included. So I'm going to put a open circle to denote that those are not included. You could also see that here with the inequality symbol. We don't have the equal part below. And as an interval, this is the one that has parentheses because at -pi/2 and +pi/2, we have undefined tangent solutions or answers. In fact, we do have those horizontal I keep saying that, vertical asymptotes. So that's why pi/2 and -pi/2 are not included. So we're going to review one more, the original graph. So the original graph for sine, it was here, and it looked like that. That was how we restricted the domain. And remember, that was from -pi/2 to pi/2. And this is sine of x. For cosine of x, we restricted our graph from here to here with an x-intercept here. So it looks like that. And then finally, for the tangent of x, we took the part that was in between the first two consecutive vertical asymptotes, one from the left and one from the right of the y-axis. So that's what we took. And because here we restricted the domain to go from negative pi over 2 to pi over 2, our range for the tangent inverse will be the same. Going back to cosine, we restricted our domain from 0 radians to pi radians, and that's why the range is that way. And finally, for sine, we restricted our domain to be negative pi over 2. Remember, we did this so they will be one-to-one functions. Because if you don't have a one-to-one function, then the inverse is not a one-to-one, it's not a function at all. So since that was the domain for the restricted domain for sine, the range of sine inverse will be that. Remember, range is your output, so those are the answers that the function, the inverse function will give you. And the domain, those are the inputs. So can you have an input here of 2? No, because it's bigger than 1. Could you have an input here of negative 10? No, because it's less than negative 1. For example 3, we're going to find the exact value. When they say exact value, they don't want your value that you get with the calculator, because it will probably be a decimal. They want an answer in radians, more than likely. And this is one of the common cosine values. So let's start by drawing that unit circle. And remember, cosine was restricted, not inverse cosine, but cosine was restricted from 0 to pi. And so that will occupy the first and the third, and I'm sorry, the first and the third, and the, I keep saying that, and the second quadrant. And in fact, our answers could be given from quadrant 1 or quadrant 2. However, for cosine, since it's related to the x values, cosine of x in quadrant 1 is a positive solution or a positive answer, when cosine in the second quadrant is actually a negative answer. So in this case, we're going to stay with the first quadrant. And I hope you recognize one of those, because it is one of the very common ones, and it's where the cosine and the sine are exactly the same, which happens at 45-degree angles, or what is pi over 4. So depending on what your question on WebAssign is asking, if they want the answer in degrees or in radians, then you will have to answer accordingly. So in my case, I'm just going to give my answer in radians, and I'm going to say that it is pi over 4. If you were to put this in the calculator, you might get the correct answer, but you might get a decimal, and WebAssign is not going to take that as the correct answer, just so you know. Next question, we're going to find the arctangent, or as we may call it, the tangent inverse of 0. Same thing, right? So let's go ahead and draw a unit circle and identify. First of all, tangent was restricted from negative pi over 2 to pi over 2 without including them, because remember, those are asymptotes. The function is not defined there. And then we will concentrate on quadrants 1 and 4. So our answer needs to come from there. So in that whole interval, remember how tangent, based on the quotient identities, is defined as sine of, if we have tangent of x, is defined as sine of x divided by cosine of x. And so at this particular point right here, at zero radians, the coordinates with respect to the unit circle are 1, 0, meaning that the sine of 0 radians is equal to 0, and the cosine of 0 radians is equal to 1. So if we want to find the tangent of 0 radians, we will of course use the sine of 0 radians in the divided by the tangent of, I'm sorry, not tangent, but cosine of 0 radians. And so we have our numbers here, and this will equal to 0 over 1, which is equal to 0. So in this case, and this is kind of like you're not really sure where it is, so I'm going to write the units. This 0 is just for the tangent value, and the other 0 that I have is actually for the angle measure, which happens to be 0 radians. And so that will be the answer. We have one more for tangent inverse, and this is the -1. Where will the tangent be over -1? So let's see. If we have our unit circle again, and remember we restricted our tangent function from -π/2 to π/2. Now let's decide this. Tangent is positive in quadrant 1 because both x and y are positive. If you divide them, you get a positive number. But in quadrant 4, tangent is negative because you have positive x's, negative y's. So when you divide those, you get a negative solution. Here we're getting a question of a negative tangent ratio. And so that tells me that we need to stick with quadrant 4. Now, I remember I said previously that at π/4, the sine and the cosine are the same, right? They're square root of 2 over 2, square root of 2 over 2. And this is at π/4. So what will happen in the negative direction? A negative angle. So that will be the angle negative π/4. So at this point on the terminal side that is intersecting the unit circle, the coordinates are positive -2 over 2 and negative square root of 2 over 2 because the x remains the same while the y value goes from positive to negative. Now, this is clear. It's telling us that this is the cosine of -π/4, and this is the sine of -π/4. So what that tells me is that if I want to find the tangent of -π/4, and that will be the sine of -π/4 divided by the cosine of -π/4, because this is one of the quotient identities. And we have the numbers here. That will be negative square root of 2 over 2 divided by the positive square root of 2 over 2. So our two fractions are the same. The answer should be 1, but we cannot overlook this negative that is actually coming from the y coordinate. So that's what makes this negative. So to answer this question, we're going to say negative π/4. We're going to go over composition of functions, and in case you don't remember exactly what they are, back in pre-cal 1, you used to work with something called f of g, not fog, but f of g. This is just a little tiny circle of x, and that was defined as the f of g of x, just like that. Now, in that back then in that section, we also looked at how inverse functions have the property that if you compose the function with its inverse, as long as you have the correct inverse, the output or the result of this will just be x, meaning the identity function. Identity because if you write the equation y equals x, you could see that the input is the same as the output. And this is the parent function for linear functions, which is here. It goes across the origin. Slope is 1, y-intercept is 0. So that is why if you want to check if you have the correct inverse function, you could do a function composition, and if you get x, that's how you know you are correct. So now we're going to try to translate this concept into our 3 trigonometric functions that we discussed: sine, cosine, and tangent with its inverse functions. So arcsine, arccosine, and arctangent, or sine inverse, cosine inverse, and tangent inverse. So we have the first property here, and this one states that if, as long as, and these two conditions have to be met, that x is equal, not equal, but is in between -1 and 1, equaling -1 and 1, or included, then if that is the case, then you could, if this one is in between that, you could kind of like when I say, how can we undo multiplication? Well, it is by division, or, how can you undo division? By multiplication. Or we say they cancel each other. And so that is the idea here, that the sine and the arcsine will cancel. But that is as long as the value for arcsine, the one that we see here, is in between -1 and 1. Similarly, if you have your sine function here, so this will be something like having f inverse of the original function. And so you will get x if the value that you have here for your angle is actually between the way we restricted the sine function. And it will have to be between -pi/2 and pi/2, including those two numbers. If that is the case, then yes, we could cancel those because they are outdoing each other, or canceling each other. I can't think of the word I want to say. But yes, now let's move on to cosine and cosine inverse. So if the function that you have inside, so you are in a situation like this, the inverse is the one that is inside the parentheses. As long as this little x, which is actually like a cosine value, is between -1 and 1, then yes, this rule will apply, and the cosine and arccosine will outdo each other, and or cancel each other out. And so the answer could just be x. Now, what if x was a number? Well, what if we had 0.5 there? Then that's what will be the answer, 0.5, after you cancel those two, whatever the number you have there for x is, as long as it is between -1 and +1, including -1 and 1. Now, if your function is something of this way, where the in this case, cosine is inside the parentheses, like we see here, the only way we could just cancel these two out is if this number which will represent something in radians or degrees, is between 0 and pi. Then our answer will just simply be whatever was the input here. So if we had, let's say, something that is between 0 and pi, we could say pi over 2. Then yes, we could go ahead and cancel that, and the answer will be pi over 2. But what if we had a 2 pi here? Then we couldn't do that, but we're going to look at how we will solve those problems. Okay, the third one here is for tangent and inverse or arctangent. And first of all, if you're in this type of situation where arctangent, the inverse, is the one inside the parentheses, like we see here, and that doesn't really have any restriction. It could be any real number. It could be as small or as um, big as you want. It could also be 0. And we're not restricted on that like we do with the uh, sine inverse and cosine inverse. So for arctan or tangent inverse, we have no restriction there. So here we will always cancel out, and the answer will just become whatever the number is there. Okay, now if we are in the other case where we have the original function being inside the parentheses and the inverse being the one outside, like we have here. So then as long as this number here is in between negative pi over 2 and pi over 2 without including those two, we are free to cancel out, and the answer will just become whatever the angle is, as long as that angle is in between that interval. So without including, so in parentheses, negative pi over 2 and pi over 2. So those are easy. You can just cancel and, solve them. But there are others where you have to do some other work. So let's look at those. So this is a very good example in which we cannot just cross this out and say, oh, the answer is 3 pi over 2. That will be counted wrong, definitely. So don't do that. So why can't we do that? Well, because the only way you could do that is if the angle that you have in there is in between that interval, negative pi over 2 and pi over 2. So if this was and including negative pi over 2, so if this was negative pi over 2, then yes, of course, it satisfies this condition. So we could cross this out because sine and sine inverse cancel each other out, and the answer will simply be negative pi over 2. However, that was not our question, so let's see what we need to do about that. So what we're going to do first is work what's inside the parentheses, and the sine of 3 pi over 2, just to remind you where we're located at. We're here at this point, and with respect to the unit circle, the coordinates there are 0, negative 1. So if we take, I'm talking about the unit circle, so I can just take the y value that we see here, which is negative 1, and that is what you guys see here. So the answer that came from here is negative 1, right there. Now that we have that, we look at the, and this was 3 pi over 2, remember? The angle, right? That was the input here. So that's how we found the negative 1. Now, for the way that we defined the sine inverse function, or the way we restricted the domain of the sine function, it was from negative pi over 2 and positive pi over 2. It's what we see here as well. So because of that, it happens that this point or that angle is actually coterminal with the negative angle negative pi over 2. They have their terminal side is on the negative y-axis. And so because of that, they do share the same value for sine. It is -1. The coordinates there are also 0, -1. And so to answer this question, arcsine of -1, the answer correctly will be -pi/2. Again, because that is the way we started the lesson, by restricting our sine function from -pi/2, pi/2. You can look at the very first slide or perhaps the third one, and we did that so to guarantee that we had a one-to-one function that could then be converted into an inverse function. Now with the next one, we cannot just go ahead and cancel those. In fact, I'm not 100% sure. I'm going to check again. So if we go back to the table, oh, actually, yes, we can, because we are in this particular case where arctan is the function inside the composition of tangent. And so in this case, we said x could be any real number. So going back to our problem, we have a -5. And so as long as this number is a real number, we could cancel, and the answer is -5. Why? Because these two are inverses of each other, so they cancel each other out. Going to our next problem, we do have sine of 5 pi/3 here, and this is one of those that we cannot cancel, and I will explain to you why. So the sine function was restricted to be in quadrants 1 and 4, or in other words, to be in the interval of -pi/2 and pi/2, just like cosine. I'm sorry, not cosine. Just forget that. So we cannot just go there and cancel them. We cannot do that, unfortunately. So what we're going to have to do, and again, I repeat, is because this angle is outside the interval that we see here. So what we need to do is solve this part first, and then we will be able to take the arcsine of that number. So to answer that question right here, let's see, actually, let's write it down below. So arcsine, and then here we're going to get the answer for this one will be placed here. So let's see what that would be. If we are in the unit circle again, and 5 pi/3 is an angle in standard position, so it starts in the positive x-axis, goes in the counterclockwise, and then it's going to stop pi/3 before it gets to a complete circle. In fact, it's a little more this way. Yeah, and I say that because I know that a full rotation of 2 pi in terms of thirds is actually 6 pi/3. So if this is, let's call it theta, this angle, it ends here. This is the terminal side. And so if that angle is equal to 5 pi/3, then the reference angle, the one that gets formed with the x-axis and the terminal side, and we call that theta prime, is going to be the difference between 6 pi/3 minus 5 pi/3. So it will be pi/3. And so we could use that as a reference to find the sine of 5 pi/3. However, sine is negative in quadrants 4 and 3 because the y values are negative there, and it is positive in quadrants 1 and 2 because the y values are positive there. So our answer will definitely be negative. but we could use our reference angle, and the sine of our reference angle, pi over 3, remember pi over 3 is 60 degrees, and my favorite is 30 degrees. The sine of 30 degrees is 1/2. So the sine of 60 degrees is not 1/2, it's the other one, the square root of 3 over 2. So that is how we use the reference angle that we have here. And we will use that value, square root of 3 over 2. Now that we have that answer, that answer is coming from here, this one. So now we could look to our numbers, our angles that go from here to here on this interval, from negative pi over 2 to pi over 2. And we could think about an angle that will be located there for which we'll have the same terminal angle. And so that will be here. And actually, I'm going to trace it with a different color. So it starts here and it ends here. And that angle is actually negative pi over 3 if we go in this negative direction. Why do I need to give my answer like that, negative pi over 3? Because our answer for arcsine or sine inverse must be in this interval here. So the answer to this question will be negative pi over 3. Let's move on to our next question. And this is with cosine inverse. Now let's think about what cosine inverse was, how it was defined, the range was going to be, and that is based on how we restricted a domain for cosine in terms of the unit circle, and that is not true. We actually used from 0 to pi, and we included 0 and pi. So in terms of an interval, our answer needs to be, or our restriction was from 0 to pi, including 0 and pi. And so in that case, we could just go ahead and, oh, actually, I just noticed this is a tricky question. Yes. So I'm going to make my own question here. Let's call this D. If the question was cosine inverse, cosine of pi, then yes, we could just go ahead and cancel here, and the answer will be pi by itself because it satisfies that condition. However, the question here, and I'm going to write an approximation of pi. So I went back a couple of slides just to show you something here. And first I'm gonna erase, I have several things here. So I'm gonna make some room. And this is exactly what I wanna show you. This problem here, or not problem, but definition, I guess. And let me just draw something around that so you know which one I am talking about. Here. This is the same as saying cosine of cosine inverse of x equals x. And that can only happen if that input is a number between -1 and 1. And so what they are showing us is the question written there. It goes like this: cosine of cosine inverse of pi, which approximately we will use 3.14 just for demonstrating purposes. So they are trying to trick us into thinking that we are actually in one of these cases where the number here could be pi, but we're not there because the function inside parentheses is not cosine, is cosine inverse, like the one we have on this side. And so 3.14, it is greater than 1, obviously. And so in this, for this one, we really cannot just cross them out because, so doing this will be wrong, so don't do it, because it's above or greater than the number 1. So if we cannot just go ahead and cancel, what is the other way to find the solution? Well, the other way will be for us to solve what's inside the parentheses first, such as that part. And then based on that answer, we will find the cosine for that particular angle and then find the answer finally. So, but here we have a problem. This question, for this question, there is no answer. It is undefined. Why? Because the cosine values, let me just use x since we're talking about it in terms of a function. For this function cosine x, the range happens to be from -1 to 1. So if we ask ourselves what is the cosine inverse of 3.14 is undefined because the domain of the cosine inverse function will be the same as the range of the regular cosine. And so it will be from -1 to 1. And so here this number goes well above that. So this is undefined. And therefore there is no answer for this one at all. So this will have no solution, no answer, undefined, DNE for does not exist, whatever option you have on WebAssign. And this is the end of the video.